Good morning, student. Today we are going to see the synthesis of crystal violet dye. Crystal violet dye is prepared by Phosen. Phosen is reacted with 2 moles of NN dimethylanilene. So in this reaction, Cl from here and hydrogen from your NN dimethylanilene goes out in the form of HCl. It is a condensation reaction going to be a form Mishler ketone. This Mishler ketone is then again reacted with NN dimethylanilene. In this reaction, the lone pair of on oxygen takes away this hydrogen and hold this part of NN dimethylanilene attached on this carbon atom. So we basically got leucobase. Leucobase is a base. It is colorless. Then this leucobase is reacted with HCl. Since it is a base and HCl is acid, they are going to be a form of salt. And this is the structure of crystal violet dye. If we closely see the structure of crystal violet dye, it is a triphenyl dye, triphenyl methane dye, because triphenyl methane group is present in the structure. So now properties and uses of your triphenyl methane dye or crystal violet dye. In basic medium, it is colorless. In weakly acidic medium, crystal violet dye give purple color. In moderately acidic medium, it give green color. In strong acidic medium, crystal violet dye give yellow color. Therefore, because of this property of color change is depend on pH, it is used as a pH indicator. It is used as a direct dye for protein fibers. It is used in the manufacturing of ink. It is used in a staining agent, and it is also used as an antiseptic due to its antimicrobial activity. Now we are going to see the synthesis of alizarin dye. Alizarin dye is prepared by the reaction of phthalic anhydride with benzene. Phthalic anhydride is reacted with benzene in the presence of aluminum trichloride. So just see in this reaction, the bond between this carbon and this oxygen basically breaks away. This oxygen takes hydrogen from your benzene and hold this part is then attached on your this carbon. So basically we are going to form orthobenzoyl benzoic acid. This orthobenzoyl benzoic acid undergoes cyclization, that is formation of ring in the presence of concentrated H2SO4. So we get anthraquinone structure. Then this anthraquinone is subjected to sulfonation reaction in the presence of fuming H2SO4. So sulfonic group is attached on your anthraquinone. So basically we got anthraquinone to sulfonic acid. This anthraquinone to sulfonic acid then reacted with NaOH, that is base. This is acid and this is base. So we basically got a salt, that is sodium salt of your anthraquinone to sulfonic acid. Then this sodium salt is undergo acidic hydrolysis and we basically got alizarin. Alizarin dye is an anthraquinone dye due to the presence of anthraquinone group in the structure. It is a ruby red color. It is used. It is the modern dye, and so it requires binder. Anthraquinone dye or alizarin basically give different colors with the different metal. With aluminium it forms rose red color, with barium it is give blue color, with chromium metal it's form brown color, and with magnesium metal it's give violet color. This dye is basically water insoluble, but it is soluble in alkali it is used in the preparation of ink. Now we are going to see synthetic drugs. First of all, what is drug? A natural or a synthetic substance which when taken into a living body affects its functioning or structure and is used in diagnosis, mitigation, treatment of or prevention of disease is called drugs. First drug is aspirin. It is also known as acetyl salicylic acid. Chemical name, IUPAC name of aspirin is 2-acetoxybenzoic acid. Molecular weight is near about 180.2. It is colorless, odorless, crystalline powder at a room temperature. The category of aspirin drugs is non-steroidal, anti-inflammatory, anti-rheumatic and antithrombic drug. First, your salicylic acid is treated with acetic anhydride. In this reaction, the hydrogen, which is the part of your hydroxyl group, is taken away by this oxygen. Because of that, this bond gets break up and this acetyl group is basically attached on your oxygen. So we got acetyl salicylic acid, that is nothing but a aspirin. Properties and uses of aspirin. Aspirin is analgesic. What is meant by analgesic? Any drug which relieves pain, used for the relief of headache and body acne and pain. It is just known as analgesic effect. What is anti-inflammatory? It is used in the treatment of inflammatory condition such as arthritis. Antipyretic, it can be used as a antipyretic drug because it reduces fever. One of the main use of aspirin is it is used in platelet aggregation inhibitor. In lower doses, aspirin can prevent dangerous blood clot from forming, so it is used preventatively to lessen the chance of your heart attack and stroke. Now paracetamol, in today's COVID-19 era, famously known as Dolo 650. Paracetamol, its chemical name, IUPAC chemical name is 4-hydroxy acid anilide. It is generally known as acetaminophen. Molecular weight is 151.2. It is at room temperature, it is white crystalline powder. First, phenol is nitrated with the help of dilute H2SO4 and sodium nitrite. So we got paranitrophenol and orthonitrophenol. The paranitrophenol then separated from orthonitrophenol, and this paranitrophenol is then subjected to reduction with the help of sodium bromohydride. It is very specific reagent. It only reduces your nitro group and converted this nitro group into amine group. Then this compound is then treated with acetic anhydride. During this reaction, acetic acid goes out and one of the hydrogen from this amine group is replaces with basically your acetyl group. So we got paracetamol. So what are the uses and property of paracetamol? It is used as an analgesic, that is its relief mild to moderate pain. Antipyretic, it is used as in reducing fever in a people of all ages, who recommended that paracetamol be used to treat fever in children only if their temperature grows greater than 38.5 degrees centigrade, that is 101.3 Fahrenheit. Toxicity, healthy adult people taking regular doses up to the 4000 milligram, that is 4 gram of a day, show little evidence of toxicity. Liver damage, it is very dangerous side effect of paracetamol. In acute doses, paracetamol can cause potentially fatal liver damage. Skin reaction, in some specific and rare cases, fatal skin reaction can be seen. Now Dettol, the active integrant in Dettol is chloroxylenol. Banskier is the manufacturer of Dettol. This is the structure of your basically chloroxylenol. In this structure we see on your benzene ring, on first position there is a presence of hydroxyl group, on 3 and 5 position there is a presence of methyl group, and at 4 position there is a presence of chlorine atom. What is category of the drug? It is used as an antiseptic and disinfectant reagent. Diluted Dettol may be used to clean cut wound, etc. And it is also used to disinfect environmental surfaces such as household floors and the walls of slaughterhouse, etc. Dettol has potential for causing lethal toxicity when it is ingested or when it is unintentionally inhaled. So now we are going to see the next drug, that is known as chloroquine. The chemical name of chloroquine is RSN-7 chloroquinoline 4-vinyl NN diethyl pentane 1,4-diamine. So just see here, it is pentane. First draw the structure of pentane 1,4-diamine. So it is 1, 2, 3, 4, 5. It is the straight chain of pentane. At first and 4 carbon we should have to draw amine group. So N, and here is NH. At 4 position, just see here N dash. It is for your this nitrogen. On this N dash there is a presence of 7 chloroquinonyl group. So we write here 7 chloroquinonyl structure attached to your N dash carbon, N dash nitrogen, and ethyl group is attached on your this nitrogen. How this drug? What is the category of this drug? It is used as a anti-malarial and antimyobic drug preparation. Chloroquine is prepared by 4,7-chloroquine with 5-diethylamino 1-methyl-butylamine. When 4,7-dichloroquinoline is reacted with 5-diethylamino 1-methyl-butylamine near about 180 degrees centigrade, this Cl from here at 4 position and one of the hydrogen of your amine group which is at the 4th position going to react and form HCl, which is goes off in the reaction. It is condensation reaction, and basically we got chloroquine. What is the property and uses of chloroquine? Chloroquine is used in the treatment and prevention of malaria. It is used in the treatment of amoebic liver abscesses. Chloroquine may be used. Since it is mildly suppress the immune system, it is used in some autoimmune disorder. What are the side effects of chloroquine? Side effects include neuromuscular, hearing, gastrointestinal, brain, skin, eye, cardiovascular, and blood reaction. In next class we are going to see synthesis of some more drugs. Thank you very much.